Welcome back, everybody. Ready for another deep dive?
Absolutely. Always ready to explore.
Me too. And today we're taking a look at flexible batteries.
Oh, yeah. Those are getting more interesting by the day.
For sure. Especially with all this new foldable tech hitting the market.
Right. Like, how do they actually make a battery that can bend like that?
Well, that's what we're going to find out.
Sounds good to me.
Yeah, we're going to be looking at a research paper from some folks over at Arizona State University.
Arizona State. Okay.
Yeah, they really put these batteries through the ringer, to see what makes them tick or maybe fizzle out.
Oh, so they didn't just look at them under a microscope. They actually tested them.
Oh, yeah, big time. And they found some pretty interesting stuff about how these batteries handle all that bending and flexing.
Okay, I'm intrigued. What kind of batteries did they look at?
They focused on those lithium polymer pouch cells, the ones you typically find in a foldable phone.
Ah, okay. Those super thin ones.
Exactly. And they didn't hold back on the testing. We're talking about thousands of bending cycles.
Thousands? Wow.
Yeah, like way more than you'd probably ever bend your phone in real life.
I mean, I guess they have to go to extremes to really see what the breaking point is.
Right, right. And it's not just about the number of bends either. They tested different sizes, to see if that made a difference.
I bet it did. I mean, a bigger battery's got to have more, I don't know, structural stuff going on.
It's true. And they even changed the orientation, bending some horizontally, some vertically.
Okay. I wouldn't have even thought about that.
Yeah. Turns out that makes a difference too. But the really cool stuff came when they started digging into the battery's inner workings. Like what's actually happening at a microscopic level when you bend these things over and over.
I'm guessing it's not just about the materials themselves, it's how they're put together, too.
You got it. They actually identified 5 main ways, 5 main failure modes that these batteries can give out.
5. That's more than I was expecting.
Me too. And they each tell us something important about how to design a flexible battery that's not only, well, flexible, but also durable.
Okay, well, now I gotta know. What are these 5 failure modes?
Let's start with one that kind of surprised me. Uneven stress distribution.
Uneven stress.
Yeah. Imagine you're, I don't know, bending a sandwich that's got more filling on one side than the other.
Oh, I see where you're going with this.
Yeah. Like the side with less filling is going to get squished more.
Right. It's not going to bend evenly.
Exactly. Well, the same thing can happen inside a battery. Those key parts, the anode and cathode, the ones that store and release the energy.
Yeah, I get it.
Well, if they're not perfectly matched in size, bending the battery can put more stress on one than the other.
Okay, so like a structural imbalance.
Yeah, and that can lead to, like, real damage, especially if you're bending it vertically. They saw this happen in the smallest battery they tested, the 15 milliamp hour one.
So it's not just about making the battery flexible, it's about making sure it can flex evenly.
Right. You got it. It's like all about balance.
Balance, okay. What about the other ones?
Well, the second one gets down to the itty-gritty, like the size and shape of the particles inside the battery.
Wait, you mean like the little bits that make up the anode and cathode?
Yep, those tiny things. Turns out, if they're too big and rough, they can actually scratch the separator. That important part that keeps everything from short-circuiting.
Oh, yeah, I remember. But you're telling me, like, microscopic scratches can take down a whole battery.
It sounds crazy, but yeah, even a tiny scratch can be a problem. It's like, imagine a tiny hole in a spacesuit.
Oh, I get it. A small breach can cause big problems.
Exactly. And it's not just the anode particles either. The way the cathode material is structured can also affect how it breaks down under stress.
Okay, so this is getting pretty complex. We got uneven stress, we got particle size and shape.
Oh, there's more. Number 3 has to do with the tab welds.
The tab welds.
Yeah, those are the points where, like, the battery terminals are attached.
Oh, right.
And the researchers found that even the location and type of weld can influence how well the battery holds up to bending.
Really? So, like, a weak weld could be a breaking point.
Exactly. They tested batteries with different types of welds, like some had a notch-based weld, others had a full-edge weld.
And I'm guessing each one had its own strengths and weaknesses.
You bet.
Yeah.
The notch-based weld actually helped reduce stress on the tab itself, but that smaller weld area was more prone to tearing.
Ah, so it's like a trade-off.
Yep. It's all about finding the right balance between strength and flexibility.
Balance again, okay.
And then the full-edge welds were generally stronger, but they were more likely to get damaged if you bent the battery in the wrong direction.
Wow. So even the way you bend these things matters.
It's wild, right? Every little detail can make a difference.
Okay, so we got 3 failure modes down. Uneven stress, particle size, tab welds. What else?
Well, number 4 gets right to the heart of what makes these batteries special, those folding points.
Ah, right. The actual creases in the battery.
Yep. And guess what? Those are some of the most vulnerable spots.
Makes sense. It's like if you fold a piece of paper in the same spot over and over, it's going to weaken and eventually tear.
Exactly. The researchers found that those folding points in some of the batteries, especially the smaller ones, were really prone to breaking down.
So, how do you design a battery that can be folded thousands of times without falling apart at those creases?
Well, that's the million-dollar question, right?
Yeah.
And it seems like the answer might lie in finding new ways to stack those electrodes, maybe using single sheets or a kind of Z-fold design to avoid those sharp creases altogether.
Ah, so instead of folding, more like rolling.
Kind of like that. It's all about distributing the stress more evenly, like spreading it out instead of concentrating it at those folding points.
Okay, I think I'm starting to get the picture here. It's like designing for flexibility isn't just about the materials themselves. It's about understanding how all those tiny components interact with each other and how those interactions change when you bend the battery.
You nailed it. It's like a whole new way of thinking about battery design.
All right, so that's 4 out of 5 failure modes. What's the last one? What have we missed?
Well, this last one's all about how you bend it.
Oh, okay, back to the bending.
Yeah. They found that bending the batteries along their longest dimension, like lengthwise, generally caused less damage.
That's interesting. So shape matters too.
It does. But it's not just about the overall shape. It also has to do with the separator again.
Okay, back to that separator.
Yeah. Think of it like a woven fabric.
Woven fabric, okay.
Yeah, like if you bend it along the grain of the fabric, it's less likely to tear than if you bend it against the grain.
Ah, I see. So the way the separator is aligned with the bend can make a difference.
You got it. It's all about understanding how those microscopic structures respond to stress.
It's amazing how much goes into designing something as seemingly simple as a battery. I mean, who knew there were so many ways they could fail?
Right. And we've only scratched the surface here. But the cool thing is, with each of these failure modes, there's an opportunity for innovation.
Oh, absolutely. By understanding how these batteries break down, we can start to design them to be stronger, more durable, and yeah, even more flexible.
Exactly. It's like by learning from our mistakes, we can create something even better.
I like that, turning failures into opportunities. So, what else did these researchers discover? Did they find any clues about how to make these batteries more robust?
They did. And this is where things got really interesting. Remember that 50 milliamp hour cell we talked about?
Yeah, the bigger one.
Well, even though it showed a lot of damage during testing, it actually performed better than the smaller cells.
Wait, really? But why? If it was damaged, you'd think it would have been the first to fail.
That's what I thought too. But it turns out this battery had an extra layer of separator.
Extra layer.
Yeah. And that seems to have acted like a kind of safety net. Even though there was damage, that extra layer provided some stability.
So like a backup system.
Exactly. Like having a spare tire, just in case. It just shows that even when damage happens, smart design choices can keep things running.
That's encouraging. It means even if we can't completely eliminate the risk of damage, we can at least mitigate it.
Right. It's all about finding ways to make these batteries more resilient, more adaptable.
This is all so fascinating. I'm starting to see flexible batteries in a whole new light. It's incredible how much science and engineering goes into something we often take for granted.
I know, right? It's like we think about folding our phones, but we don't always think about what's happening inside that battery to make that fold possible.
It's a whole microscopic world in there, and those tiny details, they matter.
They really do. All right, so we talked about 4 out of those 5 failure modes: uneven stress, particle size, tab welds, and how the bending orientation matters. What about that 5th one? What other secrets did those researchers uncover?
Well, stay tuned, folks. We'll dive into that last failure mode right after the break.
All right, so we've been talking about all these ways that flexible batteries can fail, and we've covered 4 out of 5. Uneven stress, the size and shape of those tiny particles, the tab welds, and how bending it the wrong way can cause problems.
Right, right. We've learned a lot about those microscopic details.
We have. But we still have one more failure mode to explore, and this one, it really gets to the heart of what makes these batteries unique.
Okay, I'm all ears. Lay it on me.
It's all about the folding points, those creases in the battery.
Yeah, the places where the electrodes are actually folded.
Exactly. And as you might expect, those spots are particularly vulnerable. I mean, think about it. If you fold a piece of paper over and over in the same spot, what happens?
It weakens, right? And eventually it tears.
Exactly. Well, the same principle applies to these batteries. Those repeated folds can create stress points that lead to cracks and breaks, especially when you're talking about thousands of bending cycles.
So how do you design a battery that can handle all that folding without falling apart?
That's the big question, isn't it? And it seems like the researchers are pointing towards some interesting solutions. They're talking about exploring new stacking techniques that could help avoid those sharp creases altogether.
Okay, like what kind of techniques are we talking about?
Well, they mentioned things like using single-sheet electrodes or a Z-fold design. Instead of having those hard creases, maybe you spread the stress out more evenly across the battery.
Oh, I see. So instead of a sharp fold, you have more of a gradual curve.
Something like that. It's like the difference between bending a straw and bending a cable.
Yeah, okay. The straw kinks, but the cable bends smoothly.
Exactly. And that smooth bending, that's what we're aiming for with these batteries. It's all about finding ways to distribute the stress to make the whole structure more resilient.
It makes you wonder what other innovations are out there just waiting to be discovered. I mean, we've come so far with battery technology in just a few years.
It's true. It feels like we're on the cusp of a whole new era of battery design. And who knows what those future batteries will be capable of.
I can't wait to find out. But for now, let's bring it back down to earth for a moment. This research we've been talking about, it focused primarily on the mechanical stresses, those bending cycles. But there are so many other factors that can impact a battery's lifespan.
Oh, yeah, for sure. Things like heat, how often we charge and discharge them, even just the way we handle our devices.
Exactly. And while this particular study didn't delve into those areas, it's important to remember that they all play a role.
So even though we've uncovered these 5 key failure modes, the research doesn't end there.
Yeah.
It's an ongoing process, a constant quest to understand and improve these batteries.
Absolutely. And it's a multidisciplinary effort. We're talking about chemists, material scientists, engineers, designers, all working together to push the boundaries of what's possible.
So it's not just happening in the labs, it's happening in our pockets, in our homes, in our everyday lives.
Right. As consumers, we're part of this evolution too. The way we use our devices, the choices we make, it all feeds back into the research and development process.
It's a reminder that even though we might not be scientists ourselves, we can still play a role in shaping the future of technology.
And speaking of shaping the future, I think it's time we turned our attention to the bigger picture. We've talked a lot about how these batteries fail, but what about the possibilities they unlock? What does a world powered by flexible batteries look like?
Oh, that's a question I'm excited to dive into. We've got some really mind-blowing potential applications to explore. So stay tuned, folks. We're about to take this deep dive to a whole new level. I mean, it makes you think, we talk about these fancy lab tests, but what about just everyday life? Like tossing your phone in your bag, does that do anything?
Yeah, it's funny. We worry about the big stuff like dropping our phones, but sometimes it's the little things, those everyday habits that can really impact a battery's lifespan.
Like what? Give me an example.
We'll take temperature, for instance.
What?
We all know leaving our phones in a hot car is a bad idea.
Oh, yeah.
But have you ever thought about what those extreme temperatures might be doing to the delicate chemistry inside the battery? Especially a flexible one.
I'll be honest. I haven't really thought about it that much. I know heat can be bad for electronics in general, but I never really made the connection to the battery's performance.
Yeah, and it's not just about avoiding those really extreme temperatures. Even small fluctuations can add up over time.
Oh, really?
Think about it. You take your phone from a warm pocket out into the cold winter air, then back inside to a heated room. All those transitions, even if they're not super extreme, can create stress on the battery.
Huh. I never thought about it that way. It's like our batteries are going on these tiny temperature roller coasters all day long.
Right. And it's not just heat either. Cold temperatures can also have an impact. They can slow down the chemical reactions that make a battery work.
So it's like a Goldilocks situation. Not too hot, not too cold, but just right.
Exactly. Those batteries like to be comfortable too.
Makes sense. Okay, so we've got temperature. What about humidity? Does that play a role in battery life as well?
Oh, absolutely. Moisture is a battery's worst enemy. It can lead to corrosion, which can damage those intricate internal components we've been talking about.
But I'm guessing those flexible batteries with their thinner layers and more complex designs are even more susceptible to moisture damage.
Yeah, they're a bit more sensitive, you could say.
It's kind of mind-blowing when you think about it.
Mm.
We're talking about these microscopic particles and delicate separators, and here we are tossing our phones in our bags, exposing them to all sorts of things.
It really makes you appreciate how much engineering goes into making these batteries as durable as they are.
They really are tiny technological marvels, aren't they?
They are, but even the toughest battery can only handle so much.
True, true. So apart from being careful about temperature and humidity,
Hmm.
what else can we do to keep these flexible batteries happy and healthy?
Well, let's not forget about the physical stresses we put on them.
Oh, right, like dropping them?
Exactly, or even just bending them too much or too often.
Yeah.
I mean, those folds and creases are designed to be flexible, but they're not indestructible.
So should we, like, avoid folding our phones?
Not necessarily, but just be mindful of how you're handling it. Don't twist it or bend it in ways it's not meant to be bent, and maybe don't sit on it.
Oops, guilty as charged on that one.
We've all been there, but the point is, those little actions, even if they seem harmless, can add up over time.
Like death by 1,000 paper cuts.
Exactly. Even the toughest material will eventually weaken if you stress it enough.
Okay, so we've talked about temperature, humidity, and physical stress.
Mm.
What's the bottom line? What can we do as consumers to make our flexible batteries last longer?
I think the key takeaway here is awareness. Now that we know how these different factors can impact battery life, we can start making more conscious choices.
So, like being more careful about where we leave our phones,
Hmm.
maybe investing in a good case, and just generally treating them with a little more respect.
Exactly. Those small changes can make a big difference in the long run.
It's like anything else in life. A little TLC goes a long way.
Well said. And while we're doing our part to take care of our devices, the research and development continues.
Oh yeah, for sure.
Scientists and engineers are always working on new materials and designs to make these batteries even more robust and resilient.
That's great to hear. It's amazing to think how far we've come with battery technology in such a short time.
It really is, and who knows what the future holds. Maybe one day we'll have batteries that are so flexible and durable, we won't even have to think about these things.
That would be awesome. But for now, I think we've given our listeners a lot to think about.
We've delved into the microscopic world of flexible batteries, uncovered their vulnerabilities, explored the possibilities, and hopefully sparked a little curiosity along the way.
I think we did. And with that, I think it's time to wrap up this deep dive.
Agreed. It's been a fascinating journey.
It really has. Thank you so much for joining us on this exploration into the world of flexible batteries.
It's been my pleasure.
And to all our listeners out there, until next time, stay curious, keep exploring, and don't be afraid to bend the rules of technology.
See you next time.